Newton's third law of motion states that for every action, there is an equal and opposite reaction. This principle describes the mutual forces that two objects exert on each other when they interact. These forces are always equal in magnitude but opposite in direction, and they act on different objects. The law is fundamental to understanding how forces work in the physical world, influencing everything from how objects move to how structures remain stable. When one object applies a force to a second object, the second object simultaneously applies a force of equal magnitude in the opposite direction to the first object. For example, when you push against a wall, the wall pushes back against you with an equal force, even though it may not move. This principle also explains the motion of objects like rockets. As the rocket expels exhaust gases downward, the gases exert an upward force on the rocket, propelling it into the sky. The saying "every action has an equal and opposite reaction" succinctly captures the essence of this law. However, it's crucial to note that these action-reaction force pairs act on different objects and therefore do not cancel each other out. This distinction is why objects can still move. For instance, when a swimmer pushes water backward with their hands, the water pushes the swimmer forward, enabling motion through the water. Newton's third law also governs interactions in non-obvious scenarios. In walking, for instance, when your foot pushes backward against the ground pushes you forward with an equal and opposite force. This law is equally relevant in complex systems, such as the interaction between a car's tires and the road. The tires exert a force backward on the road, and in response, the road exerts an equal forward force on the car, allowing it to move. In summary, Newton's third law of motion is a cornerstone of classical mechanics that explains how forces operate in interactions between objects. Its universal applicability spans everyday occurrences, mechanical systems, and natural phenomena. Understanding this law helps in analyzing not only simple motion but also intricate systems, enabling advancements in technology and engineering.